Hello, boys and girls. Welcome to Module 13. Only one more left. Okay, so this module deals with solutions, and every solution has two parts. A solute, like so, that is dissolved into a solvent, like so. Okay, so these are the two parts of a solution. The solute is what's dissolved into the solvent, okay? Water is the universal solvent because a lot of things dissolve in water. Not everything, but a lot do. So I'm going to make a solution by dissolving some of the solute into the solvent. When one substance dissolves in another, it creates a solution. Question: does oil and water make a solution? No, because although you can mix them together, the oil will not dissolve into the water. It will separate. Therefore, no solution unless the solute dissolves into the solvent. Okay? So, another thing you'll need to know too is a lot of solutes that we're going to talk about are solids, like salt, but there's lots of things that we could use as a solute. Sugar could even be a solute because it too will dissolve in water. But also gases can be solutes and can dissolve in water. For example, think about your Pepsi, your Mountain Dew. They have that fizz because carbon dioxide gas has been dissolved into the solvent there, and as long as it stays dissolved, then you have a fizzy Mountain Dew, Dr. Pepper, or whatever. But if that gas becomes undissolved, like it leaks out, then you have a flat drink. So you can not only dissolve solutes such as this, you can also dissolve solutes such as gases in liquids as well. Okay, so this is going to be a video talking about calculations for this module. There are two formulas that we are going to be dealing with in this class. So let's talk about this first one. Big capital M, anytime you see it, is molarity. Molarity. And this formula is also on your formula page 3 on your list of formulas. And you will see that the big capital M is molarity. Well, what's molarity? Molarity is just a science fancy word for concentration. Do you agree that when you make a solution, you can vary the concentration? If I add a little bit of salt to this water, then it's going to be pretty dilute, a lot of water, a little bit of salt. It's not going to be very concentrated. However, the more salt I add, I'm making it more and more concentrated. I'm not changing the amount of the actual solvent. I'm just making it more concentrated by adding more and more of the solute. That increases its concentration, which we call molarity. So a solution that has a lot of solute in it is going to have a high molarity, a high concentration, and a solution that has only a little bit of solute in it will have a low concentration or a low molarity. So again, anytime you see the big capital M, that is molarity. Now, how do I get molarity? Well, it has to do with how much of the solute goes into the solution, right? So if we look on the top, it says the solute goes here and the solution here. It's basically how much solute do you have in solution. And the more solute you have, then the higher molarity you're going to get. But this is where it gets picky. That solute to find molarity has to be in moles. You cannot work this problem unless you have the amount of the solute in moles. You cannot put grams in there. If I tell you you put in 5 grams of salt, you cannot put that there. You would have to convert those grams into moles before you could use this formula. This formula demands moles. So you have to know the moles of the solute over the liters of solution, and it has to be in liters. It can't go in as milliliters. It has to go in as liters. So that's something we might have to kind of tweak, not me anyway. We might have to tweak a little bit to make sure we have that amount of solution in liters. So again, very simple formula. It's just we have to make sure we have these substances in the right unit for the formula to work. Okay, that's formula number 1. Now, formula number 2 is called the dilution formula. So, I made a solution when I poured this solute into this solvent. This is a solution. If I go and pour in more water, then I'm going to be diluting the solution. And I'm going to be changing the concentration. I'm going to be making it weaker than it originally was if I dilute it with water. So this is called the dilution formula. Notice that this deals with the capital M, which is our molarity, and it deals with the V, which is our volume. In other words, the amount of the solution that is in our problem. Notice that there's 1s and 2s. These are my beginning values. What is the molarity of my solution before I dilute it? What is it initially? The volume is the volume initially. So M1 and V1 are your initial beginning values that you have before you dilute it. Now, when you pour water into this solution, you're going to be getting a new molarity because you're diluting it. So this would be your final molarity. And you're also going to be increasing the volume if you pour in water. So you're going to need a final volume. So not only when you make a dilution, you are changing your molarity and changing your volume. Okay? All right. So I say that maybe we just work maybe 3 problems or so. This would be a short video because we only have 2 formulas this time. So that should make it a little bit easier. So what I'm going to do is I'm just going to slide this over here, okay? And I'm just going to randomly pick up, why don't I just randomly pick up, here we go. We'll do this one. Okay. Calculate the molarity. I'm solving for a capital M. I know that because molarity is a capital M. Of a solution, 250 milliliters of that solution, that contains 10 grams of NaOH. So I know I have 10 grams of the NaOH, which is my solute, because that's what I'm putting into the solution. And I have 250 milliliters of that solution, and we want to know the molarity. Do you agree that molarity is only mentioned 1 time in this whole problem? There's only 1 molarity. And because there's only 1 molarity, I cannot use this formula because this one requires 2. So when I'm dealing with only 1 molarity, and I know the amount of my solute, which I do here, 10 grams of the NaOH, and I know the amount of the solution, and I do 250 milliliters of the solution, then I'm going to be using this formula here, okay? So, again, to solve for the molarity, since that's what it asked for, and I'm going to just take this up here so that you can see this. Can you see that there? Yeah, I think you can. Okay, so we need, I know I have 10 grams. So this is my solute, and I have 10 grams. But the formula tells me, you cannot put grams in there. you can only put moles. So we got to go back. We're reviewing. If you notice, even this material we're doing is still dealing with things we've already learned. So what we've got to do is we've got to take those 10 grams of NaOH and we have to do a conversion to moles. So remember, grams, so the molar mass is going to go here, and that is equal to 1 mole. So I go to my periodic table. If you remember, we need molar mass to change something to moles. And I'm going to add up Na, O, and H, okay? So Na is 20, what did I do with my calculator? There it is. All right, so Na is 22.9, and then oxygen is an even 16, and plus 1 hydrogen is 1.008. All of that equals 39.908, okay? And this is going to cancel out my grams. So I'm going to say 10 divided by 39 divided by 10 divided by 39.908. Now, what I just did was change this into moles. And it says that I have 0.25 moles. That means that I can now put that number right up there on top. I was given the grams of the solute, but I had to change it to moles so I could have what the formula wanted. So what I'm going to put in this spot is the 0.25 moles of the NaOH. That is my solute, and that goes in the top. Now, let's just say, for example, in this problem, I would have said that the solution contains 10 moles of NaOH, then you would not have to do that conversion at all. You could just put in 10 moles right there, okay? So if I give you the moles that you need for molarity, you don't have to do the conversion. You can just put it right there in the numerator and you're good to go as long as it's moles. You only have to go through that conversion process when I give you something other than moles of your solute and you have to convert it. So if I give you grams, you're going to have to convert it. All right, now let's go to the solution. It tells me I have 250 milliliters of solution. Well, the formula tells me that only liters are allowed. That's it. Only liters are allowed. So there's two ways to change this 250 milliliters into liters. I could just divide it by 1,000, because if you divide milliliters by 1,000, it will turn it into liters. Or we could Beyonce it. Now, I don't know about you, but if I can ever Beyonce it, I'm always going to choose to go the Beyonce route. So basically what I'm going to do is I'm going to take the decimal. So if I've got 250 milliliters, the decimal is back here behind this, even though you don't see it. It's at the end of the number. Or, even if it was there, wherever the decimal is. But if you don't see it, there's no decimal, it's at the end. And you are going to move it. Which way does Beyonce say? To the left, to the left. We're going to move that decimal three places to the left. To the left, to the left. Move that decimal 3 places to the left. That will change that into liters. So it's 0.250 liters. Now, when I divide 0.25 by 0.25, that is going to give me a molarity of 1. And again, molarity is the capital M. So this would have a molarity. This solution that contains this much NaOH would have a molarity, a concentration of 1 molar, okay, 1 capital M. All right, so that is that problem. So now what if I wanted to do this one? Let me put this right here. Actually, we'll take it down and get it a little closer to you. so you can read it better, then I'll stick it up here. Okay, it says how many moles, now there ain't but one of these formulas that say moles, and there it is, right? How many moles of NaCl are needed to make 500 milliliters of a 0.5, capital M, molarity, molar, whatever you want to call it, solution. But that's my molarity with the capital M. I want to know how many moles, which is that top up there, how many moles of that solute NaCl am I going to need to make 500 milliliters, which we'll have to change into liters, of a 0.5 molar solution, which would be our molarity. So we're basically going to identify that this is the formula we're going to be using, and to get the molarity, I need the moles of the solute, and do you agree that's what I'm solving for? It says how many moles, so in the top, I don't know, that's what I'm solving for. The amount of solution is 500 milliliters. So again, you can divide by 1,000, or you can take that decimal that's sitting there behind that last zero and move it 3 places to the left to turn that into 0.500 liters. Okay? And I know that the molarity, the big capital M, is 0.5 molar. Right? So this is my molarity, this is my liters of solution. So to find the top, I'm just going to multiply those together. Whenever you're looking at the number on top, if your X is on top, you just multiply the other two that you know. So we're going to do 0.5 times 0.5, and I get 0.25. So this X up here was 0.25 moles, okay? So the answer to that question, since I was solving for the moles, would be 0.25 moles. But what if, instead of saying how many moles of NaCl, because I'm going to go ahead and tell you, if I was really going to make this solution, there's absolutely no scale or balance in the classroom that will measure the salt out that I need in moles. It's only going to measure it out in grams. So to really be able to make this solution, I would need to know how many grams. So what if this read how many, and in this place it said how many grams of NaCl. So what if I wiped out moles and I said how many grams of NaCl? Well, everything I've done up until now, I wouldn't change a thing. Because, yes, I do want grams, but this formula will only solve for the moles of the solute. So I had to find that anyway first. Once I know how many moles that is, you guessed it, we're going to have to do a conversion if I want to know the grams. Now this right here is the answer to the original question, 0.25 moles of NaCl. But if it were to have said how many grams of salt would you need, then you would need to take the moles that you found and convert it. And remember, this time moles, so we need the 1 mole on bottom. The molar mass will go on top this time. And when you add up Na and Cl, you add those together from the periodic table, you should get 58.44 as the molar mass of salt. So this time we're going to be multiplying 0.25 times 58.44. And we would find out that we actually need to weigh out 14.61 grams. So if they ask you to find the grams, you have to find the moles first and then convert. Now in the problem we did before, we actually had to convert before we use the formula because they gave us grams. So just, know what you need to do there. Again, if it's something you don't understand, please text me, send me a picture of your work. I'll get you right back on track. Okay, let's do one more problem. And so let's see here. There we go. This one says 20 milliliters of a 1.2, and how do I know that that's molarity? Because it's a capital M. So this is molarity. Right here is molarity. That is a capital M right here, okay? I have 20 milliliters of a 1.2 molar solution, and it's diluted to 100 mils. So I'm going to start out with 20 milliliters of a solution, and then I'm going to pour in water and dilute it enough that I turn it and make it grow into 100 mils of the solution. Obviously, it's going to get weaker because I'm adding a lot of water. So it wants to know what the final molarity is. Now, what I want you to notice here is that this problem has two molarities. It has the beginning molarity that we have before we dilute, and then it's asking us to find the final molarity. So this formula has to have the one with two molarities, the initial and the final. So all I'm going to do is just plug this stuff in where it needs to go and know that what I'm solving for is the M2, which is the final molarity. So now the good news with this formula is you don't have to change, you don't have to have liters. You can use whatever they give you as long as they're the same on both sides. So it's not picky like this one is where it has to have liters. This you can put the volume in any way it gives it to you. All right, so molarity. What is my M1? Is my initial molarity. And my initial molarity is the first one, that's 1.2. That is my M1, okay? I'm going to multiply that by my initial volume, my first volume, which is 20 milliliters. And again, this formula is not picky. All right, so there's my M1, my V1. Now we'll go to the final side. And it tells me that I'm going to dilute it to 100 mils. This is my second volume, right? And, you know, we already established that we're solving for the M2, right? And then 100. So again, M1, V1. We're solving for the M2, which is the final molarity, and this is the final volume that I diluted it to. So we're just going to do algebra here. This is my unknown, so we're going to divide out that 100 to isolate the variable. Divide it out here as well. And once we say 1.2 times 20 equals, and then that divided by 100 gives me a final molarity of 0.24. That is my final molarity. So these are the types of problems that you're going to be working. So just remember, this is where you're just identifying the molarity of a solution based on how much of the solute in moles you put into the solution, okay? This one is the dilution when you already have the you already have a solution and you're just diluting it with water, weakening it down to a lesser molarity, okay? So give these a whirl. Again, please text me, send me pics. I can help you. All right. This is part 1, so more to come in part 2.